In this video for section 4.2, we're going to introduce logarithms. Logarithms are inverses of exponents, exponential functions. So if we look at this example here, we have y equals log base b of x. That's equivalent to b to the y equals x. So you want to pay close attention to the position of the three numbers or variables. We have the base b, we have the power y, which is the answer to the logarithm, and then x is the answer to the exponential form. So another box that shows this kind of in a more concise way is this one. Logarithmic form is y equals log base b of x. Exponential form, b to the y equals x. b is the base, y is the exponent, x is the answer. So we're going to look at example 1. We want to write each equation in its equivalent exponential form. The first one is 2 equals log base 5 of x. So 5 is the base, that's where I want to start. And then the exponent is 2, that's the answer to the logarithm. So it's 5 to the second power equals x. Now I know that 5 to the second power is 25, but for these problems in the homework, what they're going to want you to do is to leave it in exponential form so that you have all three parts of the logarithm in your answer. So leave it as 5 to the second equals x. For part B, my base is b, my exponent is 3, and my answer is 64. So b to the third equals 64. For part C, my base is 3, my exponent is y, and my answer is 7. So we have 3 to the y power equals 7. So looking at this great question box, it shows with these arrows the direction that you want to think about when you're moving from logarithmic form to exponential form. b to the y equals x. So next you should look at checkpoint problem number 1. Do this in your notes, check your answers, and then move on with the video. Next we're going to look at example 2, which is going in the other direction. Now we have an exponential equation and we want to write it into logarithm form. So I'm going to write the word log first. And then my next step is identifying the base. The base for part A is 12. And then I need to make sure that I'm writing the 12 as a subscript, and you should see the button for this in MyLab Math when you're doing the homework. Then the next thing that I'm going to write is the answer in exponential form, which in this case is x. And that's not in subscript, that's just written in regular height. So log base 12 of x equals the exponent, which is 2. 12 to the second equals x. For part B, my base is b, and then I'm going to write the 8, and that's going to be equal to 3. b to the third equals 8. And lastly, for part C, for this one my base is e, then I'm going to write the 9, and that's going to be equal to y. e to the y equals 9. So next you should look at checkpoint number 2. Do this in your notes, check your answers, and then move on with the video. Next, we're going to look at how to evaluate logarithms, and we're going to do example 3, parts A and B only. So part A is log base 2 of 16. Now remember, when we're looking for the answer of a logarithm, what we're looking for is the exponent. So what I like to do to help myself figure these out is write it into the exponential form, but use a box for the exponent that I'm going to try to figure out. So for this one, it's 2 to what power equals 16? Well, you might not know this off the top of your head, but if not, you can use a calculator and some guessing and checking. Pretty quickly, you should come up with the answer of 4. 2 to the fourth equals 16. So the answer to my logarithm is 4. For part B, log base 7 of 1 over 49. So 7 to what power equals 1 over 49. Well, the first thing that I need to remember is that if I have a 1 over, that means that my power is negative. So before we went in the other direction, we took a negative power and turned it into a fraction. Now this fraction should be a signal to us that our exponent is negative. So this is 7 to some negative power equals 1 over 7 to a positive power, which equals 1 over 49. And as you should be able to come up with, that power is 2. So 7 to the second is 49. So this is negative 2 in the box. So my answer is negative 2. So anytime you see 1 over, that should be a clue that the answer to the logarithm is negative. So next you should look at checkpoint problems number 3, A and B only. Do these in your notes, check your answer, and then move on with the video. Lastly, we're going to talk about a few simple properties of logarithms. And the first is if we have the log of a base and the number, and those two are the same, they're both b. That's always going to equal 1. And you can see that pretty clearly if you just use the same process that we were using in example 3. So if I write it out with the box, 7 is my base, to what power equals 7? Well, I know that anything to the first power is equal to itself. So it doesn't matter that these are both 7s, they could both be 1,000 or 1,000,000. Any number to the first power is equal to itself. So if they're the exact same number, then the power is always going to be 1. For part 2, log base b of 1. So if I look at b, log base 5 of 1, thinking about this in terms of the exponential equation, the question is 5 to what power equals 1? Well, as you may or may not recall, anything to the 0 power is equal to 1. So it doesn't matter what the base is here, it could be any number, but if there's a 1 after the base, then the answer is always going to be 0, because anything to the 0 power is equal to 1. So next you should look at checkpoint number 4. Do these problems in your notes, check your answers, and then move on with the video. Our last properties here are inverse properties. So we're going to look at example 5. The first one is log base 4 of 4 to the 5th. So anytime that we have the base here, and then that same base raised to a power, the answer to the logarithm is the power. So if I think about this in terms of the boxes again, this is saying 4 to what power is equal to 4 to the 5th? Well, obviously, if they're equal, and these are both 4s, then the only exponent that's going to work there is 5. So my answer here would be 5. For part B, we have 6 raised to the power of log base 6 of 9. This is also going to be equal to x. In this case, x is the number that comes after the base. And let's see why that is. So if I were to put a box here again, and this time I'm going to rewrite it into log form. So this is log base 6 of the box equals the exponent, which is log base 6 of 9. And now I can clearly see that the only thing that would work in the box is 9, because I have the same base. In order for the logs to be equal, these two numbers would also have to be equal. So my answer here is 9. So next you should look at checkpoint problems number 5. Do these in your notes, check your answers, and then you can move on to the homework.